Welcome to another X section on our lecture videos, and today I'm taking the multiple regression. Multiple regression, as we stated in class, that we have one independent variable against multiple independent variable. So it means I have multiple causes and then one effect. Okay, and that makes it a multiple regression. Forgive me for my bad writing. Again, don't forget, multiple regression is a model, so we need to come up with a model that explain whatever variables we have um, to analyze. So I'll go straight to my Excel sheet. I have an example, and then we'll use that to answer the questions that is necessary. The example is on a market value. We want to know the market value, which is against two traded stock A and then stock B. We want to see the effect of trading in stock A and stock B on the market value. So let me go to my Excel sheet here. I want to expand this a bit. I hope you can all see that. So let's do a regression multiple. This is 2 against 1. So I go to data, I go to statistics, and then regression. I choose regression. It has selected some sheets for me which I'm not so sure of, so I delete that. It says, what is your independent variable? That is your X. I have 2 of them, so I select the 2 columns here, not the month. The month is just to tell me, it's just under information, but it's not necessary for the analysis. And then it says, what is my Y? I select my sheets here. Okay, it says both X and Y has labels. Yes, both X and Y has labels. Where do you want to put the results? I want to have it somewhere here. Okay, grouped by columns, which is, so it is no rows, it is columns, please. We are still doing linear regression, and our confidence level is 95, so leave it like that. You want to calculate the residuals if you want to. Okay, all right, so let's see the things we need. We need our regression statistics. You know, that is the first part of analysis, which is the whole of this. I want to create a table as I did in the first simple one, so you get the differences. The second part is analysis of variance, that is ANOVA results. Again, that ends here. Okay, I didn't select everything. Yeah, that is that for this. Let me add some border lines. This, okay. And then we also have the third part of the ANOVA, which is our coefficient aspect. I want to highlight this. Some of you, your Excel give you a beautiful display, unlike mine, so it's still the same thing. Okay, so that's the 3 aspect. Let me have you as under yellow. So the first part, our interest will be this. I'll use blue for, I think this blue is too deep to see. Let me use this. This is the correlation. We need the adjusted R square. Okay, here to come to the significance of F. That is what we are going to use. When it gets the third part, we'll use this aspect, and then we'll also concentrate on the p-values. All right, so let me shift this Excel sheet a bit, and then have a write up a bit somewhere, and then see what we can do together. Okay, so realize that with a Excel sheet output, our R square is the coefficient of determination. We didn't have the multiple R. Multiple R would have given the correlation value. Mine didn't show. So we'll have R square, which is the coefficient of determination. Here we had R square 0.998, which is almost 99.8%. So it means that my stock A and stock B are explaining the variability in my market value by 99.8%. That means a big deal for my market value. Okay, the adjusted R square means that if I even keep on adding other variables, it will still make, I'm still going to get like 99% variability. So it means you don't even need to add more variables. Now let's come to ANOVA analysis. The ANOVA statistics, that is this part of the work, gives us how our model is reliable. Nothing different from the simple, it's the same analysis. So we are going to concentrate on the significance F. So I think I can get here as yellow as well. Okay, and then the analysis is such that if it's greater than 0.05 means we can rely on our model. If it's less than that, it means we can rely on our model. What do we have here? We have 2.61 times 10 to the power negative 10. This is almost like 0.0000, 10 zeros of 2, which is still less than 0.05. So it means that indeed our model is reliable. We can rely on this model to predict the market value for any given traded of A and then B. Okay, we are 95% assured that whatever information we are going to give you, we are good. Now let's go to the other part of the ANOVA, that is the coefficient aspect, and that wants us to write our model. So you're going to take the coefficient here to write the model. So the model market value will be equal to 0.116. Let me just choose the 3 decimal places plus 0. Let me write these things out well. So my market value will be equal to 0.116 plus 0.332 of stock A plus 0.648 of stock B. This is the model. As simple as that. I'm choosing the coefficient values here, don't forget about that. So it means by this model I can predict the market value at any given stock A and then stock B. But there's another thing you must check. Sometimes if you have more than one, you want to know which of them are even playing that role, that significant role. And as I said earlier on, that is given by the p-value of each of them. So realize that all of them are less than 0.05. No, stock A is 0. The p-value of stock A, p-value of stock A is 0.27. This is greater than the alpha value, which is 0.05 confidence interval. So it means stock A is not actually contributing to the market value, but stock B has a p-value of 0.07. This is less than the alpha. Okay, so this is how the p-value for individual variables are interpreted. Even though our model is reliable and then we have 99% variability explained, it means stock B is doing more of the work than stock A. That is what it means. Then we can come to our residual model here. Let me expand this. This is the predicted stock market. I think I'll go by this. And this is the actual stock market. I'll go by this color. And then this is the residuals. The residuals is the difference between the predicted and the actual value. So by the model, I can find my predicted. So the model is equal to, someone might not want to choose this. So let me just expand this and say my model is equal to this coefficient here plus stock A, B factor times this plus the coefficient of stock B here times that of the 3.38. It should give me the same answer. Look at it. Which color did I use? Yeah. Check this out and check this out. They are the same. So this is how you use the model. And I can drag this, but you must I can't simply drag. You must make some of the references static, like the coefficients here. The coefficients are not changing. That of the constants will not change. The factor of stock A is not going to change. The factor of stock B is not going to change. That is the only way I can get this thing right. Okay, so that is it. This means that if I know the next month trade, assuming it's 2.9, and I know the stock B is 1.7, if I know just these two values, I can predict what will happen. So it will be equal to, no, I don't need to do equal, I can drag this one. It means that if at this traded value, this will be the effect of the market value, 2.312. As simple as that for your multiple regression. At any given two entities, I can predict the market value. I hope this multiple regression has been well explained for you. It can be more than two, it can be three, it can be four. What is needed is for you to be able to write out your model very well, okay, and then check for significance and all that you want to do. As simple as that. I'll see you in the next section. Bye.